So can you explain carboxylic acid react with sodium carbonate?
Sure can.
I have a question on that.
Oh, is that particularly in the work which I've said you guys, or is that a different one?
It was from past paper.
Give me a minute. Is it the section B, the 5B?
I think so.
Okay, good. So this is one of those things. Yeah? Carboxylic acid can react not only with sodium carbonate, but also with calcium carbonate. Okay, so I'll just show you an example. So this is just using something which you know from O level. So for instance, you have, let's say, HCl plus calcium carbonate. Then you have carbonate. You have metal carbonate plus acid. So what do you get in terms of word equation? What can you tell me?
Calcium chloride.
Calcium chloride, because that is the metal salt, right? They call it the metal salt. So that is Ca2 plus Cl minus, so it's CaCl2. You should have no problem getting that. What are the other two products?
Water.
Water. And this reaction is a reaction between carbonate and acid. So when you react carbonate with acid, what do you see? It's in paper 3 as part of the observation, right? Test for carbonate. You get something else. What do you get?
Carbon dioxide.
You get carbon dioxide, but you don't see carbon dioxide. You see bubbles, you see effervescence. Now I'm going to translate that. I mean, it's the same when I do that with sodium carbonate, obviously. So Na2CO3 plus, let's say, H2SO4. So again, my metal salt this time will be sulfate because I started from sulfuric acid. So there will be Na2SO4. In fact, my equation is not balanced, by the way. So 2HCl, and I think the equation on top is balanced now. So be aware that whatever equation you write have to be balanced. Yeah? So here, 2Na, the CO3 give you CO2, and the sulfate give you sulfate. The CO3 give you CO2. One of the oxygen goes to the H2, you get H2O. So this equation is balanced like that. Your question really is asking me on carboxylic acid. What happened when you have carboxylic acid? Well, let me just show you ethanoic acid. So when you have ethanoic acid, when I react with calcium carbonate, let me make it easy. Let me choose sodium carbonate first. Okay, so the acid bit is this OH, is this H plus here. So it dissociates in water to give you H plus. So the salt that you're going to get is the one with the conjugate base. This is in the A2 acid and bases. This is what you call the conjugate base. So that is the salt that you're going to get. Carboxylic acid is the name of the acid. Carboxylate salt is the name of the salt. Okay, so what you're going to get, the metal salt here is called sodium ethanoate. So it's called sodium ethanoate because you name the acid at the end there. So whatever ethanoate, propanoate, methanoate always come at the end. So what I do is I just write CH3 COO2 minus like that, CO2 minus. I always write like that, just lose the H plus. And then what is my cation? My cation comes from the metal, is Na plus, plus 1 minus 1, so 1:1. The ionic compound, because they have giant ionic structure. And then I write down CO2 and H2O. And then I look at my formula. I always be careful with my formula. I have 2 sodium there, so I must have 2 of that. 2 of this whole thing, 2 of this whole thing, 2 of this compound, because I need 2 sodium. If you write it down as a formula, some people write it down as CH3CO2 Na. It's just that I don't really see the minus and plus. I usually always write it down like that. And when I have 2 of that, I have 2 sodium, but I have 2 of these ethanoate, which come from 2 of the ethanoic acid, which give me 2 H plus, and that goes to H2, and one of the oxygen goes there. Now, this question above was very, very tricky because they asked you on calcium carbonate. So calcium carbonate consists of Ca2 plus and CO3 2 minus. So when they ask you for this equation of propanoic acid with calcium carbonate, you're going to draw propanoic acid first, CH3, CH2, CO2H, and then you react that with propanoic acid. So you would do just like you would normally do O-level chemistry. So like I said, you lose the H plus, then you're going to get that. But then you have Ca2 plus. because you have Ca2 plus, you need more than one of these because the charges don't cancel. So what you do is the formula will be 2 of that and 1 of the calcium 2 plus. And of course, you get CO2 and H2O. Balancing our equation, you see why there is 2 marks now? Because you need to balance the equation and get the correct formula. 2 of the acid, so 2 of the acid, give you 2 of the hydrogens and 1 of the oxygen, H2O, the CO3 becomes CO2. This equation is balanced now. Happy?
Yes.
Are you okay, Rahman? Okay, now I'm going to
Yes.
show you guys, something else which is even cooler. This is called ethane dioic acid. This is in relation to your A2 transition metals, as well as the extension into A2 carboxylic acid. Okay, so A2 carboxylic acid, you have this thing called ethane dioic acid. In the A2 transition metals, you learn about the ethane dioic acid as a ligand. So dioic acid, so I'm drawing skeletal formula now, is actually HO2C, CO2H. What happens when you react that with calcium carbonate? Again, this is just your general carboxylic acid plus metal carbonate. You're going to get a salt. This is the salt that you will get. This is called ethane dioate. Ethane dioate, because it is the name of the salt that comes from this carboxylic acid. And you get a dioate because they get deprotonated completely. And your metal is calcium. So it's calcium ethane dioate. This ion is also known as the ox ligand. The ox ligand because the other name for ethane dioic acid is oxalic acid. So the salt you get is called oxalate. That is why the ox ligand refer to this bidentate ligand. Bidentate because each ligand molecule or each ligand species here, in this case is the ions, they donate 2 covalent bonds. They form 2 dative covalent bonds to the metal center. I'm sure you've learned that in transition metal. If you haven't, you will learn that very, very soon. In terms of the formula, because that is -1 and -1, overall is -2. So you just need 1 of it. You see, just now you need 2 of it, but now you need only 1 of it because there are 2 carboxylic acid components. 2 plus cancel out -2, you just need 1 of it. And of course, the other is just balancing equation, plus CO2 plus H2O. And I think your equation is balanced now. If you write it out, it will be calcium, and then you can write O2C CO2 like that. Or you can write calcium C2O4, just like that. Okay, or you can write calcium C2O4 like that. Okay, so hopefully that makes sense there. Whatever equation you write have to be balanced, yeah? So I'm open to going through section, basically there are 2 papers, right? There's the section A and then there's a section, well, not really section A and B, but more like paper 5A and paper 5B. So they are like the different sections of the AS level organic chemistry. So you have had a chance to look through the paper. So just shout out whatever question you want me to go through. I'll be more than happy to go through for you in the little time I have. Come on. Good morning, the rest of you. Hello, if you got any questions, just shout out, please. You don't have to wait. You don't have to wait for your turn. Come on, just shout out if you got any questions.
Question.
Sorry, buddy, your connection is very patchy. I'm not sure if it's on my side or on your side. Can you say that again, please?
Question for
5A or 5B?
4.
Which paper? Because there are 2 papers. There's 5A and 5B.
5B.
5B question 4. Okay. So you can ask me anything from the 5A section as well, yeah? Question 4. The whole question or specific bits?
Part A.
Part A, okay. Now, in this kind of question, this is an AS level question, right? Now, this is quite a recent paper. When I say recent, I mean in the last 4 or 5 years in the new syllabus. So they say give the structure. When the question say give the structure, guys, you don't really have to give display or structural or skeletal. You can give either. You can give either skeletal or display or structural. My personal favorite has always been skeletal. If you have gone through my topical playlist, you will know that I always emphasize skeletal, skeletal, skeletal. Why? Because how much time do you have? You have 4 minutes. If you go on and draw display for all of them, on top of going through the properties and stuff, you are really killing yourself in an exam. Okay, then you say you're not very good at skeletal. Well, there's all the time you have between now or last year, now, and also the real exam. So you have to get better at skeletal formula. It's the only way if you want to survive organic chemistry. People find organic chemistry difficult because they don't master skeletal formula. Now, the first thing we notice is these are aldehydes. Aldehyde means they have CHO, RCHO. So this is how I draw my display, my structural, and my skeletal. I don't show the hydrogen bonded to the carbon there. Now, straight chain versus branch chain. Last week, I talked about this thing called chain isomerism. So chain isomers or chain isomerism refer to straight chain versus branch chain. They are part of structural isomers. In terms of aldehyde A, they have 5 carbons. The easiest one of all is going to be this. So whatever you do when you do skeletal, count your carbon. 1, 2, 3, 4, 5. What is the name of this aldehyde? Can I ask someone to name this aldehyde for me? Afif, can you name this aldehyde for me, please? Hello, Afif. Hello, good morning, Afif. Good morning, Iza.
Yes.
Iza, what is the name of this aldehyde? Do you know how to name aldehyde?
Pentanone.
Pentanone is incorrect. You have named it for ketone. This is aldehyde. Aldehyde does not have on in there. Aldehyde has L, A-L, L, L, L. Okay, so this is pentanal. Pentanal, not pentanol. Pentanol is different. Pentanol is alcohol. Okay, pentanol is alcohol. Pentanal is aldehyde. Pentanone is ketone. Okay, be very careful, yeah? Now, people really don't like skeletal. I don't know why. If the question says structural, I'm still going to draw skeletal, but I will convert it to structural. Carbon form 4 bond, carbon form 4 bond. So I only show 1 bond there to the carbon. So that means carbon form 4 bond, I only show 1. There must be 3 hydrogen there. Carbon form 4 bond, I show 2. So how many hydrogen is here, Rahiman? Hello, Rahiman?
2.
2. How many hydrogen is here?
2.
Come on, continue.
Hello.
How many is here? Rahiman, how many is here? So carbon form 4 bond.
1 carbon.
1, 2, 1, 2. So how many hydrogen is here? We're looking at the hydrogen.
2.
2. How many hydrogen is here at carbon 1?
1.
1 is correct because carbon form 4 bond. You already have 1, 2, double, and 3. So there's 1 hydrogen. That is your RCHO, RCHO there. So if I write down the structural formula, follow where you are and do not miscount them. Structural, skeletal, they never specify. I could have gone with the skeletal and saved my time because I only have 4 minutes. I've spent a couple of minutes, explaining this. So hopefully it should make sense to you. Okay, it's all about speed, yeah? Aldehyde B is the only one with a chiral center. It exists as optical isomers. So it has optical activity. So that means it can rotate plane polarized light. There's the meaning of optical there because it's to do with light. It's to do with rotation of plane polarized light in opposite direction. So this is something you will have learned as part of enantiomers, the pair of stereoisomers, mirror images of each other, cannot superimpose them on each other. So what I have really is I can think about, so I'm drawing on the side, okay, random diagram, not even 3-dimensional, random diagram, H, and then I have 1 carbon, 2 carbon, but altogether I have 5 carbon to spare. So I can have CH3, and I can have CH3, CH2, CH3 like that. Oops, what have I done? So I can have 1 carbon, 2 carbon, so 3 carbon altogether, 4 carbon and 5 carbon, 4 different groups attached to it. Now I'm going to draw the proper skeletal formula. So CHO, and then CH, and then that. So this is the CH2, CH3. This is the CH3 there. I'm going to name this now. Find the longest chain carbon. 1, 2, 3, and 4. What is the name of this aldehyde? All of you should give it a try. What is the name of this aldehyde? Shakira, what do you get? Find the longest chain carbon and name me the longest chain carbon aldehyde first. Shakira? They don't ask you for name here, but they can ask you for name anyway. All right, Shakira, are you there? Is my internet connection really bad? Hello, hi, Shakira. Okay, no worries. So 4 carbons. So important carbon is 1, 4 carbons. So what do you name 4 carbon aldehyde? 4 carbon aldehyde. 4 carbon. What is 4 carbon? How do you name 4 carbon, Shakira? You aren't supposed to be looking at your notes. Yeah, Shakira?
Is it propanol?
It's not prop. Prop is 3. Mif.
Oh, sorry.
Mif. You don't have to be sorry. You really don't have to be sorry, okay? The AS is just coming, so you just have to be ready for it, or otherwise, they've only told you 2 years in advance that, your exams are coming, okay? So no need to be sorry. You just have to think about what will happen, a month from now when you're sitting with AS, all of you. So 4 carbon aldehyde, butanol, Al, and then I've got a branch. My branch is at position 2. So how do I name it in front? Yes, Shakira. How do I name the branch? You see the branch, you name the straight chain first, then you deal with the branches. What do I have in the branch, Shakira? Naming is the first thing they taught you, right? Yes. Yes.
2.
I still can't hear you. Are you saying something?
Is it 2? I'm not sure, sir.
You're not sure? How many carbon is here?
2. Is it 2? 2.
2 is correct, but 2 is branches. 2 is the position. What is the branch? How many carbon is in the branch? You don't know skeleton. And it's stated in the syllabus.
No.
It's stated in the syllabus. I can show you where in the syllabus, but it will be a waste of everyone's time. If you don't go through the syllabus, if you don't master something, especially when the question says give the skeletal formula, then it's game over. It's in the syllabus. Carbon form 4 bond. Carbon form 4 bond. The rule is do not show the hydrogen bonded to carbon. Do not show the hydrogen bonded to carbon. Carbon form 4 bond. You only show 1 bond here because it's bonded to carbon. So if you only use 1 out of 3, how many bond is left here? So carbon form 4 bond, that's the most important thing you can learn. Carbon form 4 bond. So you only form 1 bond here. You only show 1 bond here. How many bond is not shown? Hello, Shakira?
1 carbon, 1 bond.
You see 1 bond. You see 1 bond. But how many bonds do you not see? Because carbon form 4 bond, you see, this is the something that you have to keep on talking to your head, in your head. You say carbon form 4 covalent bond. You only show 1 bond. How many bonds are not shown here? So 4 is what the carbon form. You only see 1 because you only show 1. So 4 minus 1 equal to?
3.
3. That is because you do not show the hydrogen bonded to carbon. So there must be CH3 here. CH3 is 1 carbon. 1 carbon is meth. So that is called 2-methyl. Okay. Unfortunately, you will not have time for display formula in the real thing. And if you do in AS, you will not have that luxury in A2 at all. And you will end up not being able to read the really complicated formula in A2 organic. So be very careful, yeah? They're not asking for both. They just said the structure. So I could have gotten away with just drawing skeleton, to be honest. Now onto the actual question. We have 2-methyl group here. If you don't know what methyl group is, then how can you draw the structure, right? That's what I'm saying. So aldehyde C has 2-methyl group. Aldehyde D has 3-methyl group. So I would draw aldehyde first. Aldehyde is like that, and then methyl group is CH3, 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 I have 3 of them. Methyl group is CH3. So I only have 2 like that. Does that make sense? No, that doesn't make sense. Because then I'll have 1, 2, 3, and 4. So I need 1 more carbon. I wonder where is my next carbon. 1, 2, like that. So 1, 2, 3. Okay, I see now. If I just draw it like that, then you can see the 2 methyl group. 1, 2, 2 methyl group. And then this is 3 carbon. 1, 2, 3, 4, 5. So this one will be CH3. If I label it, oops, the longest chain carbon start from the important carbon. 1, 2, 3, and 4. So CH3CH, carbon form 4 bond. All of you, yeah, Shakira especially. Carbon form 4 bond. 1, 2, 3. How many hydrogen is here, Shakira? Yeah, Shakira.
Sorry, sir.
Carbon form 4 bond. 1, 2, 3. How many hydrogen is here at carbon number 3? Sorry, how many?
3.
You
Is it
see,
3?
you don't.
Yes.
You see 1, you see 2, you see 3. 3 plus 3 is equal to 6. Carbon form 4 bonds. Carbon doesn't form 6 bonds. You see what you see. You don't see the hydrogen. You see, that's the trick. You don't see the hydrogen. Your job is to find out how many hydrogen is there. This is not hydrogen. This is carbon. This is carbon. This is carbon. Carbon form 4 bond. Carbon form 4 bond. You show bond to 1 carbon, 2 carbon, 3 carbon. There is how many bond is left here? Carbon form 4 bonds. You form 1, you form 2, you form 3. 4 minus 3. What do you get?
1.
1. You don't see this one. Why isn't it shown? Because this one is bonded to hydrogen. So there must be 1 hydrogen there. There's the rule in skeletal formula. Now the next one, carbon form 4 bonds. So you started with 4, and then carbon form 4 bond. You only show 1 and 2. So you're left with 2. Why don't they show the other 2? Because there is 2 hydrogen here. Okay, you don't do this every single time because you are not longer in primary school. So instead, this is what you do in your head as you run through the concept carbon form 4 bond. So carbon form 4 bond, 1, 2, 3. There must be 1 hydrogen there. So it's called CHO at the end there. I've just written down the structural formula of this aldehyde, and I could do the same thing there. 1, 2, 3. So this will be CH3 there. There is no hydrogen there because carbon form 4 bond. 1, 2, 3, and 4. So this one is C. And then the branches are not part of the number in the longest chain carbon. So we put it in a bracket. And you will see all together, if you total up each of these carbon, this will be C5H3, 4, 5, 6, 7, 8, 9, 10, C5H10O. This will be C5H10O. This will be C5H10O and C5H10O. But each of them have the same molecular formula, but different structural formula. Although all of them are aldehyde, they have different structural formula because this is straight chain versus branch chain. So these are chain isomer relationship. But between these and these, there are some other relationship. For that, you need to do some naming. So I'm going to ask all of you to try. But Akila, what can you tell me about the name of these aldehyde? For the rest of you, try as well. Akila? Hello, Akila?
Yes.
What's the name of this aldehyde? Aldehyde C. Name me the longest chain carbon. 3-methyl pentanal is incorrect. Pentanal is incorrect. Look at the longest chain carbon. Butanal. That is why just now you saw me naming with Shakira. I find the longest chain carbon and then I name the longest chain below. People are confused because they see 5 carbon, they thought must be pentanal. That is only true if you are straight chain. But when you are branch, your longest chain carbon is no longer 5 carbon. That's the reason why you learn naming before drawing. And then you learn all the formulas and then you do reactivity study. Okay. So 2-methyl-butanol, 3-methyl-butanol, the relationship is going to be position isomer. You see the name is kind of similar. What you're doing is you're shifting the methyl position from 2 to 3. That's why you can see in the name. Okay. Now this thing here, who else hasn't answered this? I feel Rahiman. Okay, everyone has pretty much answered something. So I'm gonna name this for you. So 3-carbon aldehyde is propanol. And then I've got 2 branches. My branch is CH3 here. It's also CH3. So it's methyl. Methyl is called dimethyl because there are 2 methyl groups. Now this methyl is at position 2. This methyl is at position 2. So it's 2,2-dimethyl propanol. Okay, hopefully that makes sense there. This question is 4 marks. They're just looking for structure. I can do skeletal and I could do that very quickly. And I could check based on the description, 2-methyl group, 3-methyl group, chiral center there. I don't show the hydrogen bonded to carbon because skeletal formula, carbon form 4 bond, 1, 2, 3. There's 1 more left, which is not shown. So there must be 1 hydrogen there, just like that. Okay. And these are straight chains aldehyde there. So hopefully that makes sense to you, Rahiman. Drawing the 3-dimensional structures of the optical isomers. This is usually worth 2 marks, both in AS as well as A2. So make sure you know 3-dimensional means 3-dimensional. Make sure you know how to draw tetrahedral geometry. If you cannot draw tetrahedral geometry correctly, you will lose the marks because they want 3-dimensional. What is the most common mistake? People draw this. This one is 0 mark. Yeah? Because you have not shown the 109.5 degree as stated in the syllabus for tetrahedral geometry. Just now, remember I had these structures. I'm just going to quickly copy that. Okay, and then I can see for 2 marks, I really need to get this correct. So I'm just going to make my life easy and make the big one. I always make my big one on top because it's nice and easy. Some people say, but this and this are not mirror image. You want to write like this. You want to write CH2, CH3 like that. Okay, you can rotate about single bond. So even though it's mirror image like this, but you can rotate about single bond. I'm not going to write, and confuse myself like that. I'm just going to write the normal way it is because I know you can rotate about single bond. Okay. So I usually put my big group on top because it's nice and easy rather than on this side where it's not so easy to manipulate. So I put CH3 there, CH3 there, I put CHO there, put CHO there. To be honest, it really doesn't matter where you put the 4 groups. It's just that the bigger the group, the easier it is to put on top because it's easier to manipulate. Mirror image, this goes to that, the furthest goes to the furthest, this one goes to that one. This is coming up towards you, pointing at you right in the eye. This is pointing away from you, behind the screen, behind the paper. These 2 are flat. This is 109.5 degree tetrahedral geometry for this sp3 carbon there. Rahiman, do you want me to go through the rest of the questions?
Yes.
Okay, well, some of you should have tried, yeah, okay. So this one now is a chemical test. You want to distinguish any of the 4 isomers. Just now, you drew aldehyde. They told you they were all aldehydes, A to D. The other 3 structural isomers, remember last week when I said, why are ketones and aldehyde in the same topic? Why do they put this topic together? Because these 2 are what you call functional group isomer. They are part of structural isomers. So they have the same molecular formula, different structural formula, specifically different functional group. So I could have drawn a 5-carbon ketone and the other 3 structural isomers as well. So they are asking you, the other one will be ketones. They don't mention it. So this question is asking you aldehyde versus ketone, aldehyde versus ketone. A chemical test. So you can choose a few actually, and you should describe what you will see in each case, including negative results for the aldehyde. So the first one I'm going to do, you should know what is the test for aldehyde versus ketone, yeah? Very popular type of question, yeah? So the other 3 are ketones. So I could use a Tollens reagent. So Tollens reagent consists of this silver with 2 ammonia, and it's got a positive charge on the silver. It's a silver plus 1. So it's acting as an oxidizing agent. Aldehyde can be oxidized. It can be oxidized by phthalings. It can be oxidized by tollens. Ketones cannot be oxidized. cannot be oxidized. So you see why it's 3 marks? Because you got to write the observation, including the negative observation for ketone as well. So no observable change, but you will not get any marks there if you don't write what color do you see. Solution remain colorless. So tolerance reagent is colorless to begin with. Okay, it's colorless. It's not a solid, it's a solution. What you will see with aldehyde is, actually, what do you see with aldehyde? What do you see, Akila, when tolerance reagent react with aldehyde?
Silver mirror.
You get a silver mirror. So the silver mirror or silver precipitate is basically silver 0. So what has happened is silver plus 1 has been reduced. Why has silver plus 1 been reduced to silver 0? Because it has acted as oxidizing agent. Why? Because aldehyde can be oxidized by tolerance and also by phalanx, but ketone cannot be oxidized further. They are asking only for one test, but I could also have used a phalanx reagent. So phalanx reagent is not just one species, but I can tell you that it contains copper 2+ aqueous. It is very similar to Benedict reagent. You use it in biology if you do biology. Benedict reagent is used to test for reducing sugar. Every single reducing sugar is aldehyde. Every single reducing sugar contains aldehyde. So reducing sugar test, what do you see? I don't know. Who does biology? Shakira? What observation will you see phalanx reagent with aldehyde? Hello, Shakira. The rest of you should try as well. Hello, Shakira. Hello, Afif. Good morning, Afif.
Hello.
Hello. What observation will you see here?
Orange.
You don't see orange. What observation do you see here, Rahiman?
Precipitate form.
Okay, what color is the precipitate?
Orange.
You don't get orange. Okay, do you do biology, Rahiman?
Yes.
What is the test for reducing sugar? You use Benedict solution, right? What color does it become?
Yeah.
What do you see? What do you see? Benedict solution with reducing sugar.
Blue to red.
Do you get red solid or red solution?
Red solution.
Nope. You get a brick red PPT. Am I correct, people who do biology? Have you ever done this? You don't get a blue solution. The blue solution turns into a brick red solid. This is a brick red precipitate. Every reducing sugar contains aldehyde. Benedict solution, phalanx reagent, similar kind of results. This is copper plus 1 is copper 1 oxide. Cu plus or 2 minus. Even O-level students would know this, I guess. This is valency in terms of the charges of the ions. So what you get is you exchange that and you get 2 of that copper plus. This is called copper 1 oxide, stated in the syllabus as part of the naming. So what do you see here? This is negative result. So the solution remains blue. It's just the active ingredient of copper 2+ in solution. So no redox here. Here you get a redox as this oxidizes the aldehyde. The Cu2+, Cu plus 2 get reduced to copper plus 1. Now, I don't know, just now Rahiman and Afif, you keep on saying orange, 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 because what is the one that is same result? Both the ketones and also aldehyde. This is the one that will give you the same result with both the ketone and the aldehyde. Okay, they give orange precipitate, orange crystals, and this is with a reagent called 2,4-DNPH, dinitro phenyl hydrazine. In A2, you've already learned about phenyl, I believe. So what happened is hydrazine is NH2, NH2. This is just your normal rocket fuel, hydrazine. So when you have dinitrophenylhydrazine, what you get is NH2, NH, and then I replace one of the H with a phenyl. Phenyl is C6H5, but I have dinitro. Nitro is NO2, so that is position 1. So this is NO2. Let me just move that aside so you can see better. So that is your NO2 there at position 2. And then at position 4, you also have another NO2. 2 and 4 dinitrophenol for the benzenes. Hydrazine, 2,4-D and pH will give you the same observation with both ketones and aldehydes. So hopefully that makes sense there. Okay. All right, there's the whole question, 11 marks in AS. I've spent way too long because some people don't know all the stuff in AS chemistry. So there's something to do on your part. Any other questions? You can ask me the 5A or the 5B paper. Just specify which paper and which question, and I'll go through for you. Sorry, someone is speaking, but I can't hear you.
Questions.
You are breaking up really badly, actually.
Six.
Same paper, yeah? Okay. Is this the one?
Yes.
Okay. Well, with any questions, you see here, they specify they want structural. But what stops you from going through the easiest thing of all, which is skeletal? So I'm going to convert this to skeletal. This is carboxylic acid. This is alcohol. So what I do is I convert this to skeletal formula. Why? Because it's fast, it's elegant, it's easy to work with. People say, but I don't know how to do it. Well, that's why you learn. That's why you do past year papers. You learn to convert it into skeletal formula. Whatever you write, make sure whatever you draw, make sure you actually check the formula. Follow the structural formula from left to right. So CO2H, CO2H, CH2, CH2, carbon form 4 bond, check here, carbon form 4 bond. So there's 2 more left. You don't show the one bonded to hydrogen. Therefore, there must be 2 hydrogen there, CH2. Carbon form 4 bond. So there's 1 hydrogen there. So 1, 2, 3, there's 1 hydrogen there. There's OH, and then there's the CO2H. So this one is fine. Now, the reaction. This is the reaction with CH3OH and acid. CH3OH and acid. So this is alcohol. And the acid there is usually concentrated sulfuric acid as a catalyst. And this one here on the right-hand side is carboxylic acid and H+. So both of them are what you call condensation reaction. Some people say esterification. Esterification is the name of the reaction. If you look in the AS syllabus, okay, I dare you, look in the AS syllabus, you will not find esterification under type of reaction. It's not there. It's not there in the syllabus at all. The type of reaction is called condensation. When you form ester, it's called condensation. When you form amide, it's called condensation. Type of reaction, not the name of reaction. Careful, yeah? The type of reaction here is also called condensation. But yes, you are forming ester. Formation of ester is called condensation reaction. When you react with alcohol, only the carboxylic acid will form the ester. Only the carboxylic acid will form the ester. So my alcohol remains intact, but my carboxylic acid will form ester. So when I form ester, the carboxylic acid will lose the OH. So technically speaking, this one is wrong. This one is wrong. So I've lost the OH when it condenses to form ester. So essentially, this is my new alcohol, or CH3. Hang on, I've done structural. I should draw skeletal so that I am as correct as possible. So I've done this in pink so that you can see that that is the original compound there. I've reacted both the carboxylic acid with the alcohol, 1 carbon alcohol to give me the ester. This is the alcohol bit, CH3OH. This is the alcohol bit, CH3OH. Still okay so far, Afif? Can follow?
Yes.
Okay, but the one structural formula, if I do skeletal, I'm done. But if I do display from the very beginning, it's game over before I even started. Only 6 minutes, lesser than 6 minutes probably. Okay, so it's already over by the time you actually started doing display formula. So you got to read this. This is a 3 hydrogen there because carbon only form 1 bond there. So there must be 3 hydrogen. So this is CH3, or read from left to right, yeah? C double bond or, and then CH2, CHOH, and then CO2, CH3. I've written this specifically like that so that it's very clear, the structure, CH3O and then C double bond O. Okay, or I could write O2C, it's the same thing. Okay, and then all of that, CO2, CH3 there. I'm going to do the condensation on the right-hand side now. So now my carboxylic acid will not react. My carboxylic acid do not react. So what reacts? Well, what reacts will be the alcohol that reacts. So now it's the alcohol that reacts because I'm reacting with carboxylic acid. Have a look here, 2 carbon carboxylic acid. So I need to add 2 carbon carboxylic acid. I've added 1 carbon, 2 carbon carboxylic acid. What do you think you get? Break it down and try and get it back again. Yes, the alcohol remains. Yes, the 2 carbon carboxylic acid has the carbonyl bit. Now what I do is I just write, most of them are the same except for this OH, right? So I just write most of them the same as that, except for that OH. So I just copy. But this is essentially that. HO2C, CH2, CH, so CH, and then now my bracket is the tricky one. The OH has now become O, CO. So this has become O2C, CH3, and then CO2H. You can also write O and then C and then double bond O, CH3 is the same thing as long as you show the structure. Okay, hopefully you can see the 2 different esterification there. The next one, just concentrated sulfuric acid that is not condensation. So you're not doing condensation there. What are you doing there? You are using that to do dehydration. But again, dehydration is the name of the reaction. It's not in the type of reaction under AS chemistry, so it's not there. So what do you call this? The type of reaction is called elimination. Elimination of water is specifically named dehydration, but only elimination is stated in the AS under the many type of reaction. Introductory organic chemistry, have a look at. Dehydration is not there, esterification is not there, but condensation, hydrolysis, addition, elimination, those are in the syllabus. Okay, so what we're doing is we're trying to eliminate H2O. We look at the OH is there. We look at the next carbon because we're trying to get double bond, right? There is no hydrogen here on the next carbon. Okay, carbon from 4 bond, 1, 2, 3, and 4. There is no hydrogen there. Carbon from 4 bond, there is hydrogen there. So what do? I can remove the H and the OH, and I can get a double bond there. So essentially, if I draw my skeletal formula, it will look like this. I just get my double bond in between the H and the OH, so I can get that. What I've drawn is a trans isomer. There could be cis as well, but cis and trans have the same molecular formula, same structural formula. The only one structural formula. So there's no need to worry about cis and trans because it doesn't matter whether it's cis or trans, you're still going to get the same structural formula according to the definitions of stereoisomer. Okay, hopefully that makes sense there. So what I'm writing down is I show the double bonds. So this is a CO2H, carbon from 4 bond, 1, 2, 3, there is 1 hydrogen there. Carbon from 4 bond, 1, 2, 3, there is 1 hydrogen there. So CH2H like that. This is precisely what we did last week, everyone. This is to do with alkene chemistry. You remember this cold dilute acidified KMnO4, you will get oxidation, but this is the mild oxidation of alkene. So the mild oxidation of alkene does not rupture the carbon-carbon double bond. Instead, what you get is you will get diol. So it becomes OH and OH and carboxylic acid. So why do I keep on drawing skeletal formula? Because from here, I can see the double bond become OH and OH. This is oxidation of the alkene. I get diol there. This is hot concentrated KMnO4. This is extreme oxidation of alkene. When you get extreme oxidation of alkene, you get a rupture. Now here is where you need to consider breaking this. Now you remember there is 1 hydrogen here. There's 1 hydrogen there. So this is a RCH double bond. This is a RCH double bond, and they are symmetrical. So that means whatever product on the left will be the same product on the right, and the RCH double bond will get oxidized to become RCOH like that, carboxylic acid. So what I get is, well, this is what you think you will get. This is what you think you will get. So the original carboxylic acid remains as carboxylic acid. Okay, so this is what you should expect to get. So there will be HO2C, CO2H. Okay, I'm going to come back to this in a little bit, but let me just finish this one first. So HO2C, So follow this product, and this is one hydrogen there because carbon form 4 bonds. Carbon form 4 bonds, so there is one hydrogen there as well. So what's this? CHOH, CHOH, and then CO2H. They want structural formula, they don't want skeletal formula. If you try to do all of this in your head, if you try to like draw display for all of these, I wish you good luck in 6 minutes, yeah? Okay, I can do this much faster if I'm not talking. If I don't need to explain, I can do much faster, okay? This is steam because you're adding H2O onto the double bond. So you can, because it's symmetrical, you can add the H there, OH there, or you can add the OH there and the H there. That will give you the exact same product. So what I'm going to do is I will just write down the skeletal. I just write down the H there. Usually, I don't show the H bonded to carbon in skeletal formula, but I just want to show you what happened to the double bond there as I add H and OH there. So that is not really a correct skeletal formula, yeah, if you are listening, Shakira. So, you know, you need to know that you don't show the hydrogen bonded to carbon there. So there you go. That's it, really. So all of these structures, the underlying chemistry there. So after you would want to ask this question, they want structural formula. They want organic compound. Organic compound. In A2, if you look in the A2 syllabus, under carboxylic acid, you will know that this will not survive. This one will be further oxidized to become, the ethane dioic acid will not survive. It will be further oxidized to become CO2 and H2O. But these are not organic because there's no hydrogen in there. So I stop here, not because this is the final product. I stop here because the question specifies for organic product. Okay, but in reality, if this is asked in A2, you will know from your syllabus under carboxylic acid, subchloride, they said that this is further oxidized to carbon dioxide and water in the presence of this extreme condition there. Okay, now what type of reactions? Remember just now, forming the ester, malic acid, oops, sorry, this one into the C, this is not dehydration, is what you call elimination. What type of reactions? You can check out in the AS Introductory Organic Chemistry syllabus, yeah? C into D is your oxidation, and then C into E is not oxidation. I specified last week that not the carbon of the double bond, not both of them gain oxygen. Both of the carbon gain oxygen there, here and also here. These two are oxidation. This is addition reaction. They are not asking for mechanism. They are asking for type of reactions. So, you know, for that 3 marks, you don't want to lose any marks at all. So just be sensible. Now that thing there is esters. So, you know, you use it as solvent, you use it as flavorings, etc., etc. Okay, we have around 10 more minutes left. So any other question you wish to ask? Don't have to wait for your turn, just shout out. Yes, people, any other questions? You can go through 5A or 5B, up to you. Hello, hi Yasmin. Glad to have you joining us. Any other questions, guys? Well, you will have gone through the questions, right, prior to the session, I think. I don't know. Well, if you don't have any questions, why don't we just take a quick photo of attendance? Let's all just turn on our camera just for attendance. It's hard to see people are behind the screen. These questions are not so bad, yeah. These are all real AS level questions, and they are just what you're expected to be able to do, you know, in a month from now. So smile, you're on camera. Okay, one more. 1, 2, 3. All right, all good. Okay, go on then. Ask me your questions. What else do you want me to go through? I can go through a lot in 10 minutes. Anything? Anything in the papers you want me to go through? I haven't gone through the whole syllabus, yeah? That is your job. And there's only AS. And there's A2 syllabus as well. Hello, hello. If anyone's asking questions, Question 1. Is this 5B? Is this paper, yeah?
Question 9, 5A.
5A, question 9. 5A, 5A, 5A. 9, 9. Sorry, my numbering is very bad. Question 9, 5A, yeah? Okay, this is some halogenoalkane chemistry. The first thing I would do, I look at the marks. 11 marks, there's around 11 minutes. Okay, let's see if I can finish this in lesser than that. I convert everything to skeleton. Why? Because it's nice and easy. 1 carbon, 2 carbon. This is called chloroethane. 2 carbon, ethane, chloroethane. This is ethanol. And then what else do I have? I don't have anything. Halogenoalkane into alcohol. Halogenoalkane into alcohol. The Cl goes out, the OH comes in. This is replacement. So reaction 1 is called substitution. What is the substitution? OH minus replace the Cl minus. Okay, so reaction 2 is OH becomes Cl. That is also called substitution, but it's OH into Cl. Now this thing here, if you spot the dichromate, this is the Cr plus 6. You should be able to work out the oxidation number. So 2 chromium plus 7 times minus 2, giving you minus 2 charge, which is the overall oxidation number of the ion. Minus 2 plus 14 is 2 chromium. So chromium equal to plus 12 over 2. That is your orange color dichromate. You know this is orange color dichromate. It will go to chromium plus 3, which is Cr3 plus A equals, and this is green. That is because this is your oxidizing agent. So this is your oxidation of alcohol. But distill. You distill means you will collect the one with the lowest boiling point first, and you have 2 possible products. You can have aldehyde, or you can have carboxylic acid. But aldehyde cannot form hydrogen bonds, and therefore you will collect aldehyde first if you heat and distill immediately. If you want to get aldehyde, you distill. If you want to get carboxylic acid, you reflux. You don't allow it to escape. Now here, what is very important on the far left here is this is in ethanol. NaOH in water is elimination, is hydrolysis. So this is NaOH in water. It's called aqueous in water. If you have NaOH in ethanol, this is one of the most common questions that get asked in halogenoalkane chemistry. Yeah? If you have NaOH in ethanol, it's not aqueous, not in water, not aqueous. So that means you get elimination. This is the case study of elimination versus hydrolysis, which is essentially your substitution. So I put this down as substitution, but the other name they will call it is called hydrolysis. They call it hydrolysis because it's hydrolysis of the CCl, but they don't call this hydrolysis right to left because you're not hydrolyzing the carbon halogens. This is just known as substitution. This is also called substitution, but they also call it as hydrolysis because you need to break the carbon Cl bond. Now, equation for reaction 2. Reaction 2, including the reagent. So going from this to this. So some of you would have known that you can use HCl, but the normal reagent I use, because I also use it in A2, acyl chloride. I also use the exact same thing. You would have probably learned SOCl2, PCl5, something like that as well. So I can convert this into CH2Cl, and then I'll get SO2 and I get HCl. I see a steamy white film, very exothermic reaction. The Cl1 goes there, the OH comes out, and the H combined with that to give me HCl, the O combined with the SO to give me SO2. There are a couple of other things you could do. You could write the other one, CH2OH plus PCl5, and then you get CH3CH2Cl plus POCl3 plus HCl. Some people just like to use HCl. I think you can use that. Hydrogen chloride, not hydrochloric acid. Then you get H2O, and this will become Cl. Perfectly fine then. They don't say the equation, they say an equation because there are more than one choices. Now, reaction 1. Reaction 1 is your hydrolysis. So we are going to be using NaOH, aqueous. Has to be aqueous, or you say in water, and also reflux. If you just say NaOH, it wouldn't work because you need to do hydrolysis that's done in aqueous condition. Identify organic product X. This is elimination. When you do elimination, you're trying to eliminate the hydrogen from the next carbon, So what I'm talking about is you will try to eliminate this thing here for elimination. Then you will get CH2, CH2, and you will kick out HCl. They say identify, they don't say name. So you could give that, or you could give the name as ethene. That's perfectly fine there. The next one, you add some nitric acid, then you add some silver nitrate. This is part of the hydrolysis. No, this is not hydrolysis, be careful. This is elimination. So your elimination, you are trying to eliminate HCl. That was what I showed you, eliminate the HCl. So that contains Cl minus. So that means silver nitrate and HCl, you will get the precipitation reaction. So you get the Cl minus from the HCl dissolved in water. Where's the water coming from? Silver nitrate solution. Solution is in water. Hydrogen chloride gas can dissolve in water to give you HCl, hydrochloric acid, right? So you get a white precipitate. Of course, you're not allowed to use abbreviations in your theory paper. Right, and ionic equations? Well, I just did that because I know this is the kind of very popular questions that get asked. So AgCl is white precipitate, AgBl is cream precipitate, AgI is yellow precipitate, part of your paper 3 from your O-level chemistry, as well as your AS level chemistry. Identify the organic product which is distilled out. When you distill out, you always get aldehyde. You don't get the carboxylic acid because the aldehyde has the lower boiling point, because this thing here has hydrogen bonding, whereas this Y here, aldehyde has no hydrogen bonding. So if you don't have hydrogen bonds, which one will be lower boiling point? This one will be lower boiling point. The one with the lower boiling point will get distilled out first, and therefore you will collect aldehyde rather than going to the carboxylic acid, because this one with the lower boiling point, it will boil first, it will not have the opportunity to be oxidized further. So you have to compare the intermolecular forces in these, as well as the resulting product, which is the aldehyde there. So you started from 2 carbon alcohol, so you're going to get 2 carbon aldehyde, which is going to be this thing here. This is ethanol, and then when you get oxidized that, you heat and distill immediately. You're going to get 2 carbon aldehyde, CH3CHO. Aldehyde has an Al, so this is 2 carbon. This is called ethanol. Ethanol there. Okay, so I haven't really discussed the last bit, but I talked about, mentioning about the intermolecular force for this. Specified about this one is only permanent dipole because it's polar, but it has no hydrogen bond there. Which one is stronger, and which one require more energy to break, and which one has a higher boiling point, and therefore the lower boiling point will distill out first. Okay, that's all the time we have for this week. So hope it was helpful. And next week, I don't know, I guess organic is such a big topic, right? If you only look through the questions when you see me every week, it is not going to help. Okay, that's my point. If you're not very good with skeletal, work on it. I have converted this to skeletal so that I can work faster. I have done this in 10 minutes, and there is with explanation. I can actually do this a lot faster if I know my stuff, if I know my syllabus, if I know my contents. Okay, that's all the time we have today. So thank you, everyone, and have a good day.
Thank you.
Thank you, sir.
Thank you, sir.
Okay, bye, everyone.